Today, we're going to have a look at how we can use Tocker to create tables, add rows and columns to those tables, the types of data that we can store within them, and how we can actually add to those through automation, and finally, how we can link tables together using relational links. So, to create a table, you can either do it during your automation, and I'll show you that shortly, or you can create it in the data store. So let's add a data store. And you can see that we have the ability to add an item. Let's add a table. I'm going to call this people. And you can see in the middle of the screen, at the moment, we have two tabs. We have values and columns. This, at the moment, is asking us to provide columns to actually create our table model. If we want further information on tables, we can click on the right hand side and it will show us a little diagram as well as some information about tables. Let's add a new column. You can see I'm presented with a list of options. I have a label, a name, the data type for this particular column, as well as do I want to provide a default value, and is this string going to rely on multi-line information? For me, I'm going to say that my label is going to be name. And just to highlight, you can see here that in the name column, we have a much more automation friendly version of what I typed as my label. So a label may be for something that's more user friendly if someone is interacting with this data in the data store or interacting with this via an application, whereas the name of the column is something which you'll be able to use in your automation and will be much more friendly. We're going to see I can select a different type. However, in this situation, string is most appropriate for my use case here. But you can see that we've got string, which will be for things such as strings of characters, or you can have number, you can have a Boolean value, you have time and date, or together as a date time, you could have a file or an image. You could actually have JSON, you could have a unique ID using a UUID, or a table relation, which we'll touch on later. So let's select string, and if we want to have a default value, so we could say whenever a row is created, do we want it to automatically populate with a value? So let's say we're going to leave this blank. We don't want it to be multi-line because it's just going to be someone's first name. Let's do this actually. Let's do first name. Let's do last name. We'll do age, and we'll change this one to number. And then we'll do height, and we'll change this one to number as well. We can now click on add, and so now in our data store we have a table that we can now interact with in our automation or directly here. You can see we can click on edit, and we're now presented with a blank table with our column names at the top. So here we have first name, last name, age, and height. If we want to interact with these columns, we can either click on the three dots to update that column in the same menu as we saw before, or we can click on the columns tab to view this screen again, and again, edit on the right hand side. Let's start interacting with this table in automation. Let's create an activity. We can see that we can use a stateless bot because we don't need to be doing anything involving files or apps right now. And so the first thing that I want to show you can do is actually add some information to this table. To do this, we can add a row to table using the add row to table action. Here, we can see a list of options. The first of which is asking us to choose which table we want to be writing this information to. So let's click on the data chip button, select data stores and people. And once we've done that, you can see that the record is actually updated to now allow us to enter in particular fields into that table. So we have our created and updated and our ID. These are all auto-generated fields for each of your tables and will allow you to view consistent information across your tables. The ID provides a unique identifier, and the created and updated timestamps allow you to see the relative time at which things occurred, e.g. when that row was created or when it was last updated and manipulated in some way. So let's start providing some information. I'm going to say that we're going to add John Smith. He's going to be 45, and we'll say in terms of centimeters, he is 179 centimeters tall. At the bottom we have further options, which are fairly common across all actions in Docker, but we don't need to mess with these so much. If you're dealing with really large data, then we'd select using redact data, just to make it much easier on the automation going forward, as it will hide the automation from the reporting pipeline. But for most use cases, you won't need to worry about this if you're only dealing with a few records at a time. We can click on Save and run our automation. On the right-hand side of the console, you'll see that we've added a row to our table. With the information we can see listed on the right-hand side, and we can also see the row ID. This is the unique identifier for this new row that we've added. Let's add another record. Let's add someone called James Cameron. We're going to say that he's 65, and we're going to say that he's actually 156 centimeters tall. Fantastic. Let's add someone called James Jones. Let's add someone called Hakeem. And then finally, we'll add and we can see that they're very tall. So now we have some information in our table. And if we were to leave the activity and come back to our table in the data store, we can see all those values entered here. Fantastic. Let's start playing around with that information a little bit more. We can remove or add row to table, and instead, let's get table data, which will allow us to pull all of that table data or a select snippet of it into our automation. Selecting our table as we did before, we have the option if we want to get the row count, and then we have filters or sorting options. We'll come back to those shortly. Running this action, we can see that now we have the table data, along with all the unique identifiers, the created and updated timestamps, and the values that we entered. So, let's start playing around. What if I want to pull back anyone with the first name James? You can see that purposefully I've entered in two people with different surnames who share the same first name. Let's start doing so. We can come back to our action on the left, and we can apply a filter query. We can select a column, and if you already have a table selected like we do, it will provide you with a suggested list based on that table's list of columns. So we're looking for a first name that equals as the operator, and the value is going to be James. So please bring me back anyone whose first name is James. And you can see, almost like this is planned, it's brought back two values where the person is called James. Wonderful. Let's say though, I want to actually start playing around with this information a little bit more. And although we have two people called James, I only want to look for James Cameron specifically. Let's apply another filter. Last name equals Cameron. And now we have only James Cameron. Now, another way we could do this is instead of using all of these values to just whittle down to this one row, if we have the unique identifier of this row, then we can use that to actually pull back this data as well. So for us, we know that we're after this value, and we can come to our filter and we can actually do this a little bit differently. We can select ID equals and then provide our unique identifier. If we run this now, we'll also see that it returns the same row because it's matched on that piece of information. Let's say though, I actually want to update this table. We'll select it again. We can also apply a query. So which of the rows in the table do I want to be messing around with and changing the data of? And again, because there's multiple of them, for example, I want to change anyone whose name is James in some way or form. So now, again, we have this list of all the fields inside of our table for us to play with. And we can say, I want to make anyone whose name is James the age 20. Click on save. And whereas previously James was 65 years old, we can now update the table row, see that 2 records have been updated. And if we actually pull back that table without any filters on it, we'll see in our console that now we have a list of people and everyone who's called James is now magically 20 years old. So finally, I want to tap into relational linking of tables, just to give you a little snapshot of a really powerful tool that you could use. Let's go back to our data store to set this up properly. So we're going to add a new data store table. We're going to call this one address. Add some columns. We're going to add line 1. We'll add line 2. We'll add town. We'll add a postcode. And then finally, we're going to add a new one. And the first thing I'm going to do is change the type to relational. Now, what this allows us to do is to link our address table to our people table. So you can link any 2 tables that are in the same data store. If I click on this drop down menu, you'll see that it shows me my people table because they're in the same data store. And I can now say that between these 2 tables, how many things are linked. So I want to say that per one address, there can be many residents inside of that address. So in my scenario, my relationship is not 1-to-1, it's 1-to-many, because more than one person can be at an address. So let's tick this to say 1-to-many, and let's change the name to residents, since that's what I'd like to call this column. Clicking on create, you can now see that inside of the type here, we have people in our residents column. Clicking on add, our table's been added. And in here, we can actually see that if we were to add a row, we have a little bit of a different option at the bottom. So we could add and then finally, we can choose some residents who live at this particular address. So I'm going to say that John and Ben live at this address. Clicking on submit, we can now see that inside of our table, we've relationally linked 2 of the people to this address. Let's start using this on our automation. So the first thing we're going to do is instead of getting table data from our people, we can disable that for now. And we can get table data on the address table instead. And now we can see we've got that address. And we have the relational link for those 2 people. let's dive deeper. Let's say I actually want to do something with these people. I'm going to get their first and last name and I'm going to add them to a list. So let's get a for each JSON object, and I'll show you why. If we click on this button, we can view action results. Clicking on these action results, we can actually dive into our table to view the data a little bit more closely. So this is saying the first entry in this table is going to be these values. And if we click on residents, we can see the two people that we linked to this entry. And you can see that they're displayed as JSON. So we want to do something per JSON object that we find. So let's get a for each JSON object. And we can actually then use data chips to link that previous output to this for each JSON object, so long as we've run it and it's in context. So diving in, we can then select that piece of information, and that will then get populated here with a data chip, represented by anything that starts with $2 and ends with $2. Clicking on save, we can then do something per each person in that list. So let's set some actual variables. I want to get the person's first name, their last name, and I then want to add them to a list. So the first thing I need to do is actually create a list for them to be added to. So we'll add a new list called resident list. Set it to a list type and click on save. And we'll set this variable just so that we have it available to interact with later. So now we have a blank list. So let's set some other variables, and I'll duplicate this just to speed things up. Instead of resident list, I'm going to call this first name, and I'm just putting it in my description to make things a little easier for me later down the line. Set this as a string. We'll also do last name. And then finally, we'll do add to list. The list I'm going to be adding to is going to be the residence list. I want to update that variable so that it actually updates with our new information. And the item I want to add is going to be our first name, space, last name. Fantastic. So now each time this runs, it's going to set two variables, and we need to map those to our actual JSON in the moment, and it will add those variables to the list. So let's give it some context to play with. If we were to run this for now, we'll put a breakpoint in just so it stops. What we now have, if we flip over our for each JSON object, is we actually have some information in context for us to play with. So let's get our first and last names. Let's data chip for each JSON object, current JSON, and we can see inside of our record that we're currently looking at, we can select first name, and we can do the same with last name. And so now, if all goes well, we can run this as a whole, and we should end up in our variables tab with a resident list of those two people that we were relationally linking through our tables.